Okay, let's take a look at the chemical reactions. This is the definition of chemical reactions. Substances are converted into a new substance. New substances by atomic electronic arrangements, including electron transferring from one atom to another, or electron sharing between atoms. The starting substances are called reactants, and the substance formed by the reaction called products. During chemical reactions, atoms involved cannot be created or destroyed. The type of atoms cannot be changed, meaning that the Brandon number of atoms cannot be changed. All the number of each atoms in reactants have to be the same in the products. All right, that's the chemical reactions. Next, let's take a look at the chemical equations. And this is the general form. In this form, capital A, capital B are reactants, capital C and capital D are products. Okay, the small a, small b, small c, small d are called coefficient. Okay, let's take a look at the coefficients. Okay, coefficients can be the number of molecules of covalent compounds, number of atoms of pure elements, or number of ions of ionic compounds of reactants and products in a given reaction. The error in this equation is called reaction error, showing the reaction direction from reactant to products. Okay, the error is called reaction error, show the directions from the reactants to products. Okay, next let's take a look at the types of the reactions. Okay, there's five type reactions. The first one is called combination reaction. Combination reaction just join two or more reactants to form a single product. The form is like this: A plus B generates C. The examples, and here, the first one, the hydrogen, 2 hydrogen gas plus 1 oxygen gas generate 2 water molecules. And the second one, the nitrogen plus hydrogen generate ammonia. And this one is a calcium plus the bromine generates calcium bromide. Okay, this is a combination reaction. And the second type of reaction is called decomposition. It's opposite to the to the combination. Decomposition reaction is converting a single reactant into 2 or more products. Okay, this is the decomposition, and the reaction form is AB. Okay, it's a compound becomes A and B. Okay, and the examples here is like this is the first one, hydrogen bromide, and 2 hydrogen bromides decomposes into hydrogen and bromine, and this is the ammonia and form nitrogen and hydrogen. Okay, this is the decomposition. And the next one is called the single replacement. Single replacement, you can see this general form here. And on the reactant side, one is a pure element, another one is a compound. Okay, A is an element, BC is a compound. So A replace B in the BC compound to generate a B element and AC compound. Okay, this is a single replacement. You can see the example here. Zinc, copper chloride. Okay, zinc replaces copper, become a zinc chloride. This is the compound and the copper element. Okay, this is a single replacement. Single replacement must have 1 element, pure element, and 1 compound as a reactant. They also generate products of 1 element and one compound. Double replacement. Okay, double replacement is different from the single replacement because two compounds are involved as a reactants. Okay, two reactant compounds to form two different compounds. Okay, the form is here: AB plus CD. Okay, A replace C. Okay, B replace D. Okay, become AD plus CB. Okay, this is a double replacement, and two compounds interact to form different two compounds. Okay, the example is here: barium chloride and potassium carbonate. Then after this double replacement, replace barium carbonate plus potassium chloride. All right, this is the double replacement. The last one is called combustion reaction. Combustion reaction is the reaction in which a substance react with oxygen. Okay, this kind of this combustion always releasing energy in the form of light and heat. Combustion, and the combustion reaction must involve oxygen as one reactant. These are the types of chemical reactions.